Welcome to the course Algorithmic Design. I would like to now show you, continue immediately with the next example, which is a little bit related, called example Purlin noise 2D. Okay, so I'll just go here, show, and I'll just delete here. Okay, I'll just run this code. You will notice that this code looks exactly the same, and we can maybe go step by step then. But I think we'll have enough time to do that. You'll see, I'll just run it so you can see what's happening. Okay, so this is the result. This is basically an undulating terrain. This is an undulating terrain that is kind of guided by this Perlin noise. Again, this Perlin noise, we don't really have an image of it, but again, if you go online, just write in Perlin noise. This is how it looks like. Okay, so it's very, it just looks a little bit like kind of a little bit like Fogor, but it's completely procedurally generated. So it's sort of like it is some type of randomness, or this is also kind of algorithm here explained how exactly the algorithm works and so on. But it's basically some interpolation between sort of random vectors at different scales and so on. So we don't really have an image from which we work, but we use a library called Perlin. Now, I actually took this library from online. This library is just a file. So this Perlin file needs to be in your folder. And it says here, copyright Casey Duncan. Thank you, Duncan. That's it. So well, thank you, Casey. So we don't really need to go into how the library works, but basically this library produces, I think, it's made to kind of relatively quickly simulate this this Perlin noise. Also, we don't really care what's inside, but we are just using functions from this library. And specifically, we use a function called simplex noise. Okay, let's try to actually recreate this. I'll just open again my notepad, have a bit of a cheat sheet. I'll run you step to step. It's very comparable. It is almost exactly comparable to the this load height map that we had before. That's why it's a great example maybe to continue with. Okay, so now this one maybe we don't need, this we leave. Okay. Okay, so yeah, at the beginning again, same old, import rhinoscriptsyntax, rs, import. So this one I might go a bit faster. Geometry as RG, and as we are working with point clouds, again import script context, and here we don't need a system drawing, I think. No. Even though in the original example we did import it, but I think we don't need it. Okay, and then I'll save this. Again, 210323, and I will call it just Perlin noise 2D. Okay, so very simple one. And here we also need to import Perlin. So this file, this Python file, is in the same folder, and it's formatted in a way that it acts like a module, like a library, so we can import it here. We can import individual functions, so from that library. If I run it, I think everything should work. Okay. I don't also think in the example I had this enable redraw set to false, which we don't really need to have here. Okay, let's define some grid size. Okay, there's some grid size. What is the grid size? Maybe it's I think we had 300. And then we have something which we'll call sampling. So that's kind of a sampling density. Or so, so kind of how dense are we sampling this noise? And then when we sample the noise, we just get we get like a value, or which is some kind of, we can display it then as a grayscale value. So we need to additionally add sort of this Z scaling or height scaling. So before we called it height scale, here you can just call it, for example, Z scale. So what is the height scale? And maybe here it puts 10. Those are just numbers that I know that work, so I just put them in here. Okay, so whatever number we get from the, yeah, because also I remember the Perlin noise, so not this image, but this image here. So Perlin noise, the numbers that we get are from 0 to 1. So they are kind of normalized to this domain from 0 to 1. So different than what we had before with the grayscale image, but from 0 to 1, that means that our height is then, would be below 1 Rhino unit, which is quite low. So this needs to be kind of a bigger number. So we will scale this by 10. So then the highest number will be 10 units, 10 Rhino units. The smallest one will be, I guess, 0. I'm not sure if he here also, I'm not sure if it goes, I think he also goes into 0. So maybe it's from, I'm not really sure if Perlin noise goes also to 0. I can actually check here. If it goes underneath line 0. Yeah, it actually goes into 0. Okay, so the numbers are, I guess, from -1 to 1. Okay, so this is just some variables at the beginning. Okay, yeah, and then there's this, when we're using this Perlin library, we have to create this Purlin generator. So that's an object, it's like an object, which will generate our Perlin noise. So we can call it Perlin gen, like a Perlin generator. And we can use it, it's Perlin dot, and here it offers it's already simplex noise. So simplex is just a term for that type of noise. So there are, I think, multiple ones. I think the simplex noise, it's just designed in a way so that you can calculate it really quickly. Because again, if you use interactive applications, you need to run these functions, function like maybe a million times a second or something. So you want it to be really, really fast. So this simplex algorithm was developed specifically for that, to be kind of fast. It's called simplex noise. Okay, and then as before, we have point cloud. So rg dot point cloud. Okay, so that's going to be our point cloud, which will hold our points. So our noise will be, this noise will be interpreted as a surface. And yeah, the value of the noise will be mapped to height. And the cool thing about this noise is that it is gradual, or so it is continuous. That's why here it looks like a smooth surface, or because there are no big jumps. Or okay, and I think that's it. I think around this should work, but nothing really happens. Okay, and now we have a nested loop. Again, we have a grid, so we have nested loop, 2 nested loops for x in range. So for x in range, and then it's just going to be grid size, and we'll work with the rectangular square grid. So for y, same thing. So we have also x and y will be the same. It's just simpler. We can have them different, but here we'll just have it like that. Okay, and so what is, when we sample the noise, what is this noise? This noise is just a number, and we will just call it immediately a z, or so it's going to be a z value. So we have x coordinate, y coordinate, which is like just a regular grid. So when I go on the top, it becomes very regular. Or if I look this from the very top, it just looks like a square grid. That's it. So x and y are there, and but I will use z, or so the z will be we will sample the noise, and this will become my z value. Okay, so now I have to query the Purlin generator, or that's an object. And if I say dot, again, unfortunately, there's no autocomplete here, but the method is called noise2. And yeah, so we could basically just put x and y inside, but actually we also have this sampling factor, or so this, we multiply our x and y with this sampling, and it's because we want to, so this sampling is basically controlling the scale in x and y direction. And again, if the sampling is a different number for x and y, we'll just get, it's as if you take the surface and you kind of stretch it and squeeze it, for example. Okay, and then all of that, actually make it bigger. All of that this whole number, this is now a number from 0 to 1, or from -1 to 1, I apologize. This we will multiply with z scale. So this number here. So we'll just kind of make it bigger or smaller. And that's it, that's our z, that's our, that is our z coordinate. Then we will attach a point to that, to those coordinates. Point is, again, rg.point3d, convenient. And yeah, we use just x, we use y, and then we just use z. So here we already calculated what the z is, so we can just put it in. Let's not do, well, actually we need to give it a color. So actually I just realized, yeah, I actually realized that, okay, so if I use point cloud, yeah, I think I need to use color, okay. If I use point cloud object, there's an attribute called, or method called add. And for this add, I give it a point and I give it a pixel. Yeah, I realize now why I need system drawing. Okay, so I'm adding a point to the point cloud, but I also need to give it a color. Okay, and this pixel, I need to, this noise does not really give me the color. This color and noise, they have nothing to do with each other. So this noise is a number and color is something else. So I will not connect them now, but I actually have to give it, I need to create this pixel object, or and I can do it by, I actually do need to import, or this import. So I have to go at the beginning, system.drawing as SD, okay, because then I have my point and I have my pixel. Pixel is, so there's again a method from this library, sd dot color dot from RGB. Okay, so this is actually from, I guess this is alpha RGB. I guess so. Okay, so I can just define a color in RGB coordinates here. And if I put 0, 0, 0, this is black. This is black color. And now this is my pixel. So pixel just goes in here. Later we can actually, I can show you, you can play a little bit with this color. You can make it, you can give it a different color if you want, and maybe we can actually try that as well. But for now, we just leave it black. And that's it. So now my point cloud is created. And at the end, I need to do this complicated, you know, this script context. I need to add this script context dot doc dot objects. That's the object table dot add point clouds, and the point cloud is, that's the object here. And then additionally, I have to do this script context dot doc dot views dot redraw. Okay. Okay, and that's it. Basically, this will draw. So this will add the point cloud to the objects table, so Rhino can find it and draw it, and this will actually redraw the whole Rhino screen so that it actually shows. And that's it. If I can save it, I can run it. Okay, and this is not, I mean, it's random, but basically the sampling, I think the seed is fixed, or so I can change, for example, this sampling to, for example, 1, and you will just see how the surface changes. Okay, so this is when I sample a surface, so I kind of squeezed everything down, or I can do the opposite, or I can go like this, make it a bit smaller number. Now it should, I just realized that I'm overlapping everything. Okay, so it's this again. I maybe need to add this kind of a, you know, objects equals rs dot objects by layer from the layer default, and then rs dot delete objects. Okay, so now I'm going to delete, which is before I kind of start. Okay, so now I get this kind of very smooth one, and if I choose this sampling like 10 times bigger, then I will get this kind of very jagged or and basically this is like a 3D version of what you have here, or more or less. I think, or it should be. Okay, so it's like a kind of a quasi-periodic. Well, it's not. It's like quasi-random surface. Okay, and just to go again, maybe 5 here. Okay, so I can change, and then of course with this Z scale, I can also change this, so I can make it kind of more flatter, or if I put 50, it should go way up. It should become very, very kind of jagged. So on this side, it becomes very, very messy, but from the top, you can start seeing kind of a little bit pattern. Okay, so this is basically just how I'm sampling the noise. And actually, there's one other thing that we didn't add, which I'll try now. Actually, 10, maybe this one puts 2. So we have something like before. Okay, I actually want to show you. There's one other parameter that you can do. You can add offset. Okay, so there's sampling, and there's offset. You can add an offset. Offset will kind of shift this whole pattern, up, right, or somewhere. So maybe you can put offset X. So in the X direction, offset is maybe, it's a bit hard to know what is the best number, but maybe 0.1. Okay, so we will just add here in this, when we sample the noise, in the X, this X sampling, we'll just add this offset X. Okay, so if I run it, we get the same thing, but it is a bit shifted. I'll just save the version. Okay, and so I'm trying to save 2 versions now. Okay, it is a bit subtle, but basically there are 2 point clouds now, and one of them is shifted. Or so actually make it bigger. So one of them has an full screen. Okay, there are 2 point clouds. You can see this if I click, it kind of offers me 2 of them. They're in different layers. Actually, maybe I can kind of again. Okay, so look, there's 2 point clouds, 1 point clouds, 2 point clouds, 1 point cloud, and this is again, I hope I'll pronounce it correctly. It gives me this kind of more effect, or because I have sort of 2 grids that are almost matched, but they are a little bit offset from each other. Also, it's this is how I can do this. I'll try to Google it. You probably know it. Moire effect. Okay, Moire effect. Okay, so Moire pattern. Also, it's a little bit related to that. When I have kind of it's basically when I have kind of patterns, and then I'm they are kind of almost aligned, but kind of shift them. Sometimes the lines, the patterns, they kind of align. Sometimes they misalign, and this creates these sort of a weird wavy patterns. So that's a little bit what's happening here. And there's another effect in nature, which is a little bit related to this. It's called iridescence. I learned how to pronounce this because we had a project which is called iridescence print. Iridescence. So I learned I learned the word. So iridescence is it's maybe this, or so that's this kind of a shiny, like colorful, like rainbow effect that you have maybe you can see in nature, and you get it. It's similar to this Moire effect, but basically have 2 films. 2 films, and then you have kind of refraction, like different refraction, different refraction kind of happening. You have kind of interference between sort of two images that are slightly shifted from each other, because one of them is created on top of the film or reflected from top of the film. The other one is reflected from the bottom of the film, and film is of course very thin, but this is enough to create sort of this interference. So basically, when the film changes thickness, the color changes. Or so basically, these different colors are mapped to sort of different, like super tiny differences in thickness of the film at that position. And I think, again, something similar is happening to this. You can do this effects in kind of porcelain and I guess kind of, skins of these insects and so on. So this kind of a rainbow type patterns, this is called iridescence. And it is a little bit related to this kind of, difference in kind of thickness of the film. Also, you have these few effects that you can sort of simulate by this way. And let me just try to do this one more time in Rhino. I can just actually go here, change layer 1. Of course, change the color, but currently, let's actually play a little bit with the color. So I'll just do X offset one more time. So now I'm going to get a third one. Okay. I think eventually it might become too messy, but now there are actually 3 point clouds. Or if I click there, there should be 3 point clouds somewhere here. Yeah, there are kind of 3 of them. 1, 2, 3. So 3 layers. Let's try to just, one last thing that I would like to do is just to play a little bit with color. So if I go here, I can change the color. So let's create the first one. Maybe I delete this one here. And let's create some shade of, so let's say I want to create like a magenta color, but I don't know actually what the RGB value of magenta is. So I can find this out in different ways. Can go online, but I will just check it quickly in Photoshop. So in Photoshop, I can maybe find the color that I like and just put it in here as value. So I don't have to kind of pinpoint. I think magenta is some combination of like red and blue. Okay, new, create, and I just want to, I hope you can see my Photoshop screen. I just want to find this, just quickly choose the color. Okay, here, color picker. Yeah, okay, magenta is somewhere here. Okay, so it's like red full channel, green 0, blue full channel. Okay, so it's a combination between 255. So it's a combination between kind of full red and full blue with no green channel. Gives me this kind of a pinkish magenta, I guess. I guess it's somewhere there. Okay, so let's try to recreate that. So here, this is red, 255, and green is 0, and blue is 255. Okay, so when I create this, I will get like a pink or magenta. Okay, like a point cloud. I'll just change the background a bit to white. Okay, and now I will create maybe a few more. Maybe we can add now, can add like blue. So RGB blue, so maybe this one here. Oh, sorry. So I have to just change layer here. So change layer to maybe the layer 1, so it will not be deleted. In the code, I change now to blue color. So if I run it, oh, okay, again, I have to do the offset R. So offset X, it should be 0.1. I run it. Okay, so now I got, it's a bit kind of so this is now sort of a combination between blue and magenta, and let's kind of drive it all the way around. Maybe we just add like some green or something like that. 255, I don't know what this is. Let's see in Photoshop, what is this? So, 0, 255, okay, it's some kind of a bluish, I guess this is cyan or something like that. So let's try that. Change layer 1. I'll just run it all. Oh, again, undo, we have to do, of course, the offset. And now I'm doing it a bit manually, but you could, of course, do a code that does exactly. Somehow it created it. Again, I realized, let's run 255 here. Now, correct. Okay, so it is a little bit hard to see, but there's now a third, so there are kind of 3 okay, there are three different point clouds, and they're a little bit shifted from each other. Of course, I could shift them in different ways. I can, for example, say I'm shifting them somehow in the z height. This is like shifted in like x, for example. But I could shift them in different ways to get different different effects.